Matt Armstrong's Bugatti Veyron rebuild now sits at a point that once sounded completely unrealistic, 90% complete. That number carries more weight than it seems at first glance. This wasn't a straightforward restoration, or even a typical rebuild. It began with a severely damaged car that even Bugatti's own leadership dismissed as impossible to repair outside their official network. Every attempt to source parts was denied. Critical components had no public documentation. The W16 engine, one of the most complex power units ever made, had never been independently reassembled in a situation like this. Even specific structural components, like the gearbox mounting bracket, were widely considered beyond repair. Yet despite all of that, nearly everything that once seemed like a dead end has already been solved. The progress so far is difficult to overstate. The bracket that many believed would end the project was not only repaired but improved through precise welding and reinforcement. The car itself, once split apart to access its most critical sections, has been carefully reassembled and aligned. The W16 engine didn't just turn over, it started immediately, a strong indication of internal integrity. The gearbox engages as it should, smoothly cycling through gears. The car has already moved under its own power, a milestone that transforms it from a static project into a functioning machine. Inside, the transformation is just as striking. A completely unique interior has been installed, featuring a bold combination of purple and white leather across custom seats. Details like laser-cut airbag covers and carefully integrated safety components show how much effort went into making the cabin both functional and refined. Airbags, sourced from different manufacturers, have been adapted and fitted, while original systems have been reset and brought back into working condition. Seatbelts have been recharged with fresh explosive mechanisms, restoring their safety functionality. Even elements like radiators, fabricated from unconventional components and engineered to fit this specific build, are now installed and connected. The chassis itself, including a reconstructed leg, has been restored to a standard that visually and structurally matches factory quality. With so much already accomplished, the focus naturally shifts to what remains. The final 10% is not about solving impossible problems anymore. It's about completing a series of precise, critical steps that will turn this functioning machine into a fully road-legal hypercar. These remaining tasks are fewer in number, but still demand accuracy, patience, and in some cases, cooperation from sources that have not been helpful so far. The first issue to address is a radiator leak. After installation, the custom-built radiators were pressure tested, and one of them revealed a small but noticeable leak. The cause isn't a flaw in fabrication, but rather damage sustained during transport, where part of the assembly likely made contact with something and compromised the core. Fortunately, this is a problem with a clear solution. The same person who built the radiator will repair it, using the correct materials and techniques to restore its integrity. It's a relatively quick fix in terms of actual work, but until it's resolved, the cooling system can't be filled, and that prevents the next, far more significant step. That next step is the coolant fill and temperature test, which is arguably the most critical moment of the entire rebuild. The Veyron's cooling system is incredibly complex, holding around 40 liters of coolant distributed across multiple circuits, each responsible for different parts of the car. Filling it correctly isn't as simple as pouring in fluid. It requires a vacuum process to eliminate air pockets and ensure proper circulation. Any trapped air could create localized overheating, which in turn could damage seals, gaskets, or internal engine components. What makes this test even more important is the car's history. At one point earlier in the project, the engine was run without coolant, meaning heat was generated without proper regulation. The extent of any resulting damage has remained unknown ever since. This upcoming test is the first real opportunity to find out whether that moment caused lasting harm. When the engine runs with coolant properly circulating, Several indicators will reveal its condition. The temperature should rise steadily and then stabilize within a normal range. The oil should remain clean, without any milky discoloration that would suggest coolant contamination. The overflow reservoir should stay calm, without continuous bubbling that might indicate combustion gases leaking into the cooling system. Together, these observations will provide a clear verdict on the health of the engine after everything it has been through. There are reasons for optimism. The engine's immediate start earlier in the process suggests strong compression and properly functioning internals. Smooth idling and consistent behavior also point away from major issues. While none of this guarantees a perfect result, it does build a case that the engine is in far better condition than worst-case scenarios would suggest. Beyond the mechanical side, the car still needs exterior work. Some panels are either missing or temporarily fitted, and areas affected by structural repairs require proper paintwork. This stage is less about engineering challenges and more about precision and finish. However, timing is critical. There's no point completing paintwork before confirming that all mechanical systems are functioning perfectly. If further engine work were needed, completed paint could be damaged or undone. That's why this step comes only after the cooling system and engine have been fully verified. Once the car is mechanically sound and visually complete, the focus shifts from engineering to legality. A car that runs in a garage isn't automatically allowed on public roads, especially one with a salvage history and extensive modifications. It must pass a detailed inspection process that evaluates everything from structural integrity to emissions and safety systems. Particular attention will be given to repaired components like the gearbox bracket, the rebuilt chassis sections, and the modified exhaust system. Each of these must meet strict standards, regardless of how well they were engineered. One of the most challenging hurdles, however, lies in the car's electronic systems. After a crash, certain modules enter a fault state that requires specialized tools to reset. In this case, clearing those fault codes depends on proprietary diagnostic equipment controlled by the manufacturer. This is the same manufacturer that refused to supply parts or support earlier in the project. Now, at the final stage, access to their system becomes necessary, even if only briefly. Whether that access comes through unofficial channels, changing regulations, or some form of cooperation remains uncertain. What is clear is that without resetting these systems, the car cannot pass inspection in its current state. This makes it one of the few remaining variables that isn't entirely within the team's control. If everything goes as planned, the sequence of completion is straightforward. The radiator is repaired and passes pressure testing. Coolant is added correctly, and the engine proves its reliability under proper operating conditions. Exterior panels are fitted, and the car receives its final paintwork. Inspection confirms that all structural and mechanical aspects meet required standards. The electronic systems are reset, clearing any fault states. Finally, the car is registered, insured, and approved for road use. At that point, the transformation is complete. What began as a wreck deemed beyond repair becomes a fully functional road-legal Bugatti Veyron. Not just a car that runs, but one that can legally drive on public roads, carrying with it the proof of everything that was accomplished over the past 14 months. The finish line is now clearly visible. The remaining steps are defined, the challenges understood, and the path forward mapped out. After overcoming obstacles that once seemed insurmountable, the final phase is no longer about proving possibility, it's about completing what has already been proven.